Hey guys, Miss Timmons here, and welcome to your Atomic Structure Wix number 2, objective number 2 video. If you have not taken the time already, go ahead and make sure that you set up the questions for today's Wix. The first part of today's Wix, we're going to kind of review some of the stuff that we've talked about previously, and then we will kind of dive into the new components. I will apologize, I'm going to move the video camera around periodically throughout the video just to make sure you can see most of it. I'm trying to keep it up, but I may have to take it down during certain parts so that I don't block out any information. So let's get started. So just a couple things that I want to review from your previous video. In objective number 1, we focused on the parts of the atom that pertain specifically to the nucleus. So we talked about the protons. Protons had a positive charge and a mass of 1. They're found in the nucleus. The protons are what identifies an element. So if an element has 35 protons, then it's the element bromine, because bromine is number 35. We also talked about the neutrons. Neutrons have a neutral charge. It also has a mass of 1 and is found in the nucleus. The reason these masses are important is when we determine the mass of a particular atom of an element, all we have to do is count up the total number of protons plus the total number of neutrons, put that number together, and that gives you your mass. Electrons, which are what we're going to be talking about today, they actually have a very, very small mass. It's actually 0.001, and we'll get into that in a second. But because they're so small, they are not included in the overall mass of the atom. The way I kind of describe this, it would be like if you get up in the morning and you go step on the scale and you look at the number on the scale and then you go eat one Cheerio, just one Cheerio, and step back on the scale, you probably should not see a change in that number. Now if you eat like a pound of Cheerios, then you would see a change, but if you just eat one, that one Cheerio doesn't have enough mass to change the number on your scale. Same thing with the electrons. They're there, but they're too small to have an impact on the mass. Electrons also have a charge of -1, and they are actually found outside of the nucleus, since that's what we're going to be focusing on today, is the outside of the nucleus, in what's known as the electron cloud. You may also hear it referred to as the energy levels or the rings. All of those are referring to the same location. So let's talk about mass, volume, and charge. This is a table that some of this information we talked about in objective number 1 again. So the nucleus has all of the mass. It is very, very small, so the volume that it takes up is quite small. However, it has all of the mass, so all of the mass in a very, very small amount of space. It also has a positive charge, and here's why. You have positive protons on one side, and you have neutral neutrons. They can't cancel each other out because the neutrons don't have a charge. Because of that, your charge is strictly based on the number of protons. If you have 5 protons, you have a positive 5 charge. That is only true for the nucleus in the center. The electron cloud has almost no mass because the electrons are too small, and it's mostly empty space because the electrons are so spread out that there's just a lot of empty space in between them. It does also have a negative charge because all of the electrons are negatively charged. Okay, so this is a chart that you saw in objective number 1. The only difference is we're going to add the next subatomic particle to it. So in video number 1, you wrote down that you have the proton is in the nucleus, positive charge, 1 atomic mass unit. Neutron in the nucleus, neutral charge, and 1 atomic mass unit. So here's what we're adding today. The electron has a negative charge. Let's see if I can bring it up. There we go. It's found in the electron cloud, has a -1 charge, and a mass of 0.001. What that means is it would take actually 1,000 electrons to equal the mass of 1 proton or 1 neutron. Again, this is just why we don't count it when we look at the mass of the atom. So there are two different forces at work when we look at the atom. There's the force of repulsion, meaning that they push each other away. The positive protons actually repel one another because two positives want to move away from each other. The neutrons are actually the particle there that kind of holds all of it together. Then you have the force of attraction. The force of attraction is actually where the protons hold the electrons in orbit, kind of like gravity would. There's an attraction between the protons and the moving electrons. That's why the electrons orbit around the outside of the nucleus. All right, so ions. I'm actually going to move the camera down a little bit. So ions. There are two types of ions. You have anytime an atom loses an electron, meaning if you have 5 positives and 5 negatives, but you take one away, okay, let's see if I can do this backwards. Take one away, okay, 5 positives and only 4 negatives, your overall charge is actually a positive 1. That's called a cation. It's a positive ion. You can also have a negative ion, which is where you actually gain an extra electron, and that is where the atom then would be negative because you have more negative electrons than you have positive protons. Okay, let me move this one more time. A neutral atom gains or loses electrons. The atom will have a net charge, will have no net charge. It'll have a neutral net charge. What that means is if the positives and the negatives are equal, then your charge is neutral or 0. Electrons can move from one energy level to the next, but only valence electrons, meaning the ones on the very outside of the atom, have the ability to move from one atom to another. So the only way you can lose an electron is if it's on the valence ring, the outside ring. So a model that illustrates the structure of the atom. So this is lithium, and inside of lithium you should have 3 protons. Most lithium atoms have 4 neutrons, and then you have, if it's a neutral atom, 3 electrons, 1, 2, 3. Now, there are 2 limitations to this model of the atom. Number 1, the size of the nucleus in the electron cloud. If we were to draw this whole thing to scale, the size of this nucleus for each of these would actually be too small to see, because in reality the nucleus is a whole lot smaller compared to the rest of the atom. The other thing is size and placement of the electrons. Electrons would also appear a lot smaller because they have such a small size, and they don't move in one direction. So it's they're orbiting in all directions around the nucleus of the atom. So that's very difficult to model in 2 dimensions, which is why this is a limitation of that model. So drawing Bohr models. So let's take magnesium for example. We're going to draw a neutral atom of magnesium. That means they'll have the same number of protons as we have electrons. So if we work through this, you just kind of bear with me because we're going to go through each one. In a neutral atom of magnesium, the protons is always equal to the atomic number. So this number up here in the top corner, that is 12, so I have 12 protons. A neutron is equal to the mass subtracted by the atomic number, so it's 24 minus 12. We're going to round. And then the electrons, because it's a neutral atom, is going to be equal to the protons. So kind of take a look at this. We use ape. So atomic number is equal to protons is equal to electrons. This is only true, this last part is only true in a neutral atom. And then we do man. So mass minus atomic number equals neutrons. So if you remember Ape Man, then that'll kind of help you work through each of those subatomic particles. So we have 12 electrons. The charge of the nucleus is a positive 12. Just going to work through our electrons. Oh, there we go. So the charge of the nucleus is a positive 12. The charge of the electron cloud is a negative 12 because there are 12 negative electrons. If you put those two together, then you have an overall charge of 0, which we did say we were going to work with a neutral atom, so that's true. The mass of our atom is 24. Okay, so now let's look at sodium. So same thing. So we have Ape Man. So atomic number equals protons equals electrons, because this is again in a neutral atom. So protons is equal to 11, because our atomic number down here is 11. Our neutrons is mass of 23 minus the atomic number of 11 equals 12 neutrons. Electrons is 11. Charge of the nucleus is the number of, let's get all of our electrons out there again. Charge of the nucleus is the number of protons. Charge of the cloud is the number of electrons. Overall charge is 0, and then our mass is 23. So now let's see what happens, and I'm going to move my face again. Now let's see what happens if you have an element that has a charge, an overall charge, meaning the number of protons and the number of electrons are not equal. So you still treat protons the same. So if this is number 13 is aluminum, okay? Aluminum is number 13 on the periodic table, so I have 13 protons. Okay, I still do neutrons the same. Mass minus atomic number equals neutrons. Now look at this model of aluminum that I have over here. I have 2 on the first ring, I have 8 on the second, but I only have 2 on the third. So that means I have a total of 12. My charge is still my protons of the nucleus. The charge, though, of my electron cloud this time is only negative 12. So if I compare these two numbers, positive 13 and negative 12, that means I have an overall charge of positive 1. And the mass of our atom is 27. Okay, try this one more time. So number of protons, and I'm going to have you do this on your own. The other ones we kind of walked through. This one I'm going to have you do on your own in your notes and bring it to class. One of the things that we'll be checking as you bring your homework to class is that you have all of the answers for number 15, phosphorus, done on your own. So that is all for today. Don't forget to go back and complete your supporting item and have your homework ready for class. Bye, Bengals.